Hi, I am Teacher Daisy. Now, let's learn Form 5 Chapter 1 Variation. In this chapter, you will learn 1.1 Direct Variation, 1.2 Inverse Variation, and 1.3 Combined Variation. Variation. Variation is defined by any change in some quantity due to change in another. In this chapter, you will learn 4 types of variation, which are direct variation, joint variation, inverse variation, and combined variation. 1.1 Direct variation. Direct variation explains the relation between two variables, such that when variable y increases, the variable x also increases at the same rate, and vice versa. Relation between two variables. For a direct variation, the variation relation, y is directly proportional to x. Variable y varies directly as x. As x increases, y also increases. As x decreases, y also decreases. Example: the total wage of a part-time worker varies directly as the number of hours he works. What will be the total wage he receives if his number of working numbers is doubled? Solution: since his working numbers is doubled, increased by the same factor, thus, the total wage is also doubled. Relation between two variables. For a direct variation, the equation form of direct variation is y equals kx, where k is the constant of proportionality. Since y equals kx, k equals y over x. The graph of y against x is a straight line that passes through the origin. K is the gradient of a straight line, passes through the origin. The graph must pass through the origin, because if x increases by 0, y increases by 0 also. The different values of k gives different slopes of the graph. In general, for a direct variation, in variation relation, y varies directly as x to the power of n. In equation form, y equals kx to the power of n, where n equals 1, 2, 3, half, 1/3, and k is a constant. The graph of y against x to the power of n is a straight line, passes through the origin, where k is the gradient of the straight line. For instance, y varies directly as x squared, y equals kx squared, k equals y over x squared. Example: a toy car moves from a state of rest. The distance traveled by the toy car, y changes with time, t. Determine whether y varies directly as t or t squared. Hence, write the relation in the form of variation. Solution: y varies directly as t, because the value of y over t is a constant. Hence, y does not vary directly as t squared, because y over t squared is not a constant. Example: A. By drawing the graph of y against x, determine whether y varies directly as x. B. By drawing the graph of y against x squared, determine whether y varies directly as x squared. Solution: A. The straight line does not pass through the origin. Hence, y does not vary directly as x. B. Calculate the x squared. After that, draw out the graph y against x squared. The straight line passes through the origin, hence, y varies directly as x squared. Example: it is given m equals 0.8 when n equals 0.125. Express m in terms of n if a. m varies directly as n. b. m varies directly as the cube root of n. Solution: m varies directly as n. M equals kn. To find out the constant k, substitute the value into m and n. 0.8 equals k times 0.125. K equals 0.8 divided by 0.125 equals 6.4. Hence, m equals 6.4n. Solution: B. M varies directly, as the cube root of n. M equals k times cube root of n. To find out the constant k, substitute the value into m and n. 0.8 equals k times cube root of 0.125. K equals 0.8 divided by cube root of 0.125 equals 1.6. Hence, m equals 1.6 times cube root of n. Example: it is given y varies directly as x. If y equals 0.14 when x equals 0.2, calculate the value of y when x equals 5. Solution: y varies directly as x. Y equals kx. To find out the constant k, substitute the value into y and x. 0.14 equals k times 0.2. K equals 0.14 divided by 0.2 equals 0.7. Hence, y equals 0.7x. Now, we will calculate the value of y when x equals 5. When x equals 5, substitute x into the equation y equals 0.7x. Y equals 0.7 times x equals 3.5. Example: the period of oscillation, a seconds, of a simple pendulum varies directly as the square root of the length of its string, PCM. It is given that the 9 cm string of the simple pendulum oscillates for 1.2 seconds. Calculate the period of oscillation in seconds if the length of the string is 25 centimeters. Solution: A varies directly as square root of p. A equals k times square root of p. To find out the constant k, substitute the value into 1.2 into a, and 9 into p. K equals 1.2, divide by square root of 9, equals 0.4. Hence, a equals 0.4 times square root of p. When p equals 25, a equals 0.4 times square root of 25 equals 2 seconds. Thus, if the length of string is 25 centimeters, the period of oscillation is 2 seconds. Let us now move on to the second type of variation, joint variation. A joint variation is a direct variation, in which one variable varies as a product of two or more variables. Y varies jointly as x to the power of m and z to the power of n. In variation relation, y directly proportional x to the power of m and z to the power of n. In equation form, y equals k times x to the power of m and z to the power of n, where m equals 1, 2, 3, half, and so on, n equals 1, 2, 3, half, and so on, and k is a constant. Example: write the relation using the directly proportional symbol, and in equation form for each of the following. A. P varies directly as q, and surd r. B. Y varies directly as the square of w, and the cube of x. Solution: A. P varies directly as q, and surd r. In equation form, P equals k times q surd r. B. Y varies directly as the square of w, and the cube of x. In equation form, y equals k times w squared and x cubed. Example: Given that x is directly proportional to y squared z, express x in terms of y and z, if x equals 6, when y equals 3 and z equals 5. Solution: write the relation in the form of equation. X equals k times y squared c. Substitute the values of x, y and z into the equation, to obtain the value of k. 6 equals k times 3 squared times 5. K equals 6 divided by 3 squared times 5. Equals 2 over 15. Hence, x equals 2 over 15 times y squared, z. Example: 3 quantities, s, t, and u vary as shown in the table. It is given that s varies directly as t, and the cube root of u. Calculate the values of x and y. Solution: s varies directly as t, and cube root of u. S equals k times t, and cube root of u. S equals 6, when t equals 0.8, and u equals 27. Substitute the values into the equation to find the constant k. 6 equals k times 0.8, and cube root of 27. K equals 6 divided by 0.8 times cube root of 27, equals 2.5. Hence, s equals 2.5t, and cube root of u. When t equals 1.2, and u equals 125, to find the value of s, substitute the values into the equation. S equals 2.5 times 1.2 times cube root of 125 equals 15. When s equals 50 and t equals 40, to find the value of y, substitute the values into the equation. 50 equals 2.5 times 40 times cube root of y. Cube root of y equals 50 divided by 2.5 times 40 equals 0.5. In order to get the value of y, we need to get rid of the cube root. Cube both left and right hand side. Thus, y equals 0.5 cubed equals 0.125. Now let's move on to 1.2 inverse variation. In inverse variation, variable y increases when the variable x decreases at the same rate and vice versa. Relation between two variables for an inverse variation. In variation relation, y directly proportional to 1 over x to the power of n. Variable y varies inversely as x to the power of n. As x to the power of n increases, y decreases. As x to the power of n decreases, y increases. In equation form, y equals k over x to the power of n. K equals x to the power of n times y, where n equals 1, 2, 3, half and so on, and k is the constant of proportionality. The graph of an inverse variation. The graph of y against x to the power of n is a hyperbola, where x is not equal to 0. The graph of y against 1 over x to the power of n is a straight line that starts from the origin. Example: 2 quantities, x and y, vary based on the table. By using a suitable scale, draw the graph of y against 1 over x, and show that y varies inversely as x. Solution: the graph of y against 1 over x shows a straight line that starts from the origin. Hence, y varies inversely as x. Example: it is given that x equals 0.25 when y equals 3. Express y in terms of x if a. y varies inversely as x. b. y varies inversely as the square root of x. Solution: a. y varies inversely as x. y equals k over x. To find the value of k, substitute y and x into the equation. 3 equals k over 0.25. K equals 3 times 0.25 equals 0.75. Hence, y equals 0.75 over x. B. Y varies inversely as the square root of x. Y equals k over square root of x. To find the value of k, substitute y and x into the equation. 3 equals k over square root of 0.25. K equals 3 times square root of 0.25 equals 1.5. Hence, y equals 1.5 over square root of x. Example. It is given that p varies inversely as q. If p equals 2, when q equals 7, calculate the value of p when q equals 1.6. Solution. P varies inversely as q. P equals k over q. To find out the value of k, substitute p and q into the equation. 2 equals k over 7. K equals 2 times 7 equals 14. Hence, p equals 14 over q. When q equals 1.6, p equals 14 over 1.6 equals 8.75. Lastly, we move on to 1.3 combined variation. Relation between 3 or more variables. For a combined variation, y varies directly as x to the power of m, and inversely as z to the power of n is written as below. Where m equals 1, 2, 3, half, and so on, n equals 1, 2, 3, half, and so on, and k is a constant. Example. It is given that y varies directly as the square of x, and inversely as square root of z. If y equals 8, when x equals 4 and z equals 36, express y in terms of x and z. Solution. Y varies directly as the square of x, and inversely as square root of z. Y equals k times square of x, divide by square root of z. To find out the value of k, substitute x, y, z into the equation. 3 equals k times 4 squared, divide by square root of 36. K equals 8 times square root of 36, divide by 4 squared, equals 3. Hence, y equals 3 times x squared, divide by square root of z. Example. The table shows the values of p, q and r. It is given that p varies directly as the cube of q and inversely as r. Calculate the values of x and y. Solution. P varies directly as the cube of q and inversely as r. P equals k times q cubed, divide by r. 4 equals k times 2 cubed, divide by 0.6. K equals 4 times 0.6, divide by 2 cubed, equals 3 divide by 10. Hence, p equals 3q cubed, divide by 10r. When p equals 3.6, q equals 6 and r equals x, p equals 3q cubed divide by 10r. Substitute p, q, r into the equation. 3.6 equals 3 times 6 cubed, divide by 10x. X equals 3 times 6 cubed, divide by 10 times 3.6, equals 18. When p equals 0.081, q equals y and r equals 2.7, p equals 3q cubed divide by 10r. Substitute p, q, r into the equation. 0.081 equals 3y cubed, divide by 10 times 2.7. Y cubed equals 0.081 times 10 times 2.7, divide by 3. To get the value of y, cube both side and become y equals cube root of 0.081 times 10 times 2.7 divide by 3 equals 0.9. The concept map for Form 5 Chapter 1 variation is as follows. If you find this video helpful, don't forget to like, share and subscribe our channel. And if you got any question can comment below. Thanks for watching.